Let's work through a more interesting example. This one's going to be a system that generates movie recommendations to people at a very large scale based on other movies that they've liked in the past. So let's start by working backwards. What does the end user actually want to see? That's the one thing that's really non-negotiable in this whole thing. Well, they want to discover movies that they haven't yet seen that they might enjoy. So, well, that's not terribly useful because it's a very vague statement, but that's really all the customer knows about the problem. That's how they think about it. So sometimes you need to innovate on behalf of the customer and figure out creative ways of giving them what they don't even know they want. Well, let's think about it. Their own behavior is probably the best predictor of movies that they might like. So if they liked a certain set of other movies, you can probably figure out what new movies that they haven't seen are similar to those movies that they might also enjoy. We also know that since we're dealing with an online system on a very big website, availability and partition tolerance are very important. We cannot tolerate downtime on this website. And we know there are enough people hitting this system that we need to distribute the vending of this data. So we need availability and partition tolerance. Consistency, less important, although that's going to be a little bit of a tricky question there. So given that consistency is the least of our worries, Cassandra is going to be our go-to choice. But really, any NoSQL approach would probably fit the bill. And this is important because this is an interesting example where as we work backwards, we're going to discover new things about how we need to deal with this problem that might make us go back and revisit some of these assumptions. And this is in fact one of them. Cassandra might not be what we end up using in the end, so let's keep an open mind on this. But right now, at this stage in our thought, Cassandra might be a good choice. Okay, so let's imagine we are using Cassandra. How do I get recommendations for movies into it? Well, this gets a little bit dicey, right? I mean, to make movie recommendations, that's a hard problem. That's like machine learning stuff, like maybe artificial intelligence even. Okay, well, Spark has a machine learning library called MLlib. Maybe we can use that. Or Flink has a machine learning library as well. They can both do recommendations. In fact, Spark's MLlib has a thing called ALS that can actually generate individual movie recommendations for you. So it's built in as a feature of that library. So, okay, that seems like it might be good. But let's think about the timeliness that the customer might expect. Doing machine learning on this kind of a scale is going to take a lot of time and a lot of resources, even on a cluster. So we have to ask ourselves, how soon do these recommendations need to respond to new movie ratings? So let's go back and think backwards from the customer experience again. If I'm a customer and I rate a new movie like Star Wars 5 stars, do I expect my movie recommendations to reflect that information pretty soon? Yeah, I do, actually. If I've just watched my first movie in your system and I rate it and I give you that information, I expect to get something back right away. If I tell you I like Star Wars, then I expect you to tell me that I might also like The Empire Strikes Back. I mean, it's probably not the best recommendation because you probably already knew that, but it's an example. So timeliness is important, and the idea of computing individual movie recommendations for every user that's ever used your website continuously, that's a waste of resources. So let's go back and think about this problem more creatively. Pre-computing recommendations for every user just isn't practical. It's a waste of resources. You're going to be computing recommendations for people that'll probably never come back to your website again for that matter. So let's instead think of a way of computing recommendations on the fly, quickly, on demand. And at this point, you'd probably go off and look at some other ways or some research on how other people have solved this problem, and you would find something called item-based collaborative filtering. The idea here is that the thing that you do the heavy lifting on, the machine learning, is just the relationships between movies. So based on past consumer behavior, people who liked Star Wars also liked The Empire Strikes Back, and they also liked Indiana Jones, right? So that's what's important to get here, and that can be updated more infrequently because these relationships between movies do not change quickly. However, your behavior as an individual does change quickly. So the idea is to very quickly be able to retrieve your past ratings of movies or your past purchases or your past views, whatever behavior data you're working with, get that up to the minute, and then go refer to a separate database of similar movies to movies that you've liked in the past. Put together the list of all the movies that are similar to ones that you've liked in the past, filter out the ones you've already seen, and those become your recommendations. So I'm greatly oversimplifying how this works, but that's the general idea. From an architecture standpoint, what does this mean? It means we need some system that is infrequently, potentially, updating the movie similarities, movies that are similar to each other data, and very quickly providing access to my past ratings and behavior data. So the actual We're probably talking about some intermediate layer of services that puts all that information together and generates your recommendations. That's going to be a fairly complex operation, so you're probably going to have your own service running on its own cluster of machines that actually talks to the system that we're building and puts those components together to generate recommendations. So, where are we at? We're going to build some web service to put these components together. So, speaking in terms of our system, what we're going to build is some sort of a fast data store to retrieve the movie similarities data. So that service will need the relationships between movies, and that data can be updated infrequently, but it needs to be available very quickly when it's called upon. We're also going to need to have fast access to your past ratings and purchases. So we need to get up to the second data about stuff that you've rated and bought in the past so that we can use that as the input for our movie recommendations. So the key here is it's probably going to be pretty easy to expose access to my past behavior data as an individual. The movie similarities, that's the hard part. That's the heavy lifting, but that can be done less frequently. So here's one architecture that might make sense. This is one thing that I came up with. And again, there's more than one way to do it, and we'll talk through that as well. So the thing that we're starting off with is consumer behavior data. What movies are people rating? We need to get that information and store it. So as people rate individual movies, maybe we can pick that data up from the web application servers using Flume, just because it happens to have a good integration with our servers that we're using. Kafka could work as well here. And we can dump that into some system to extract the actual behavior data that we care about, specifically that customer X rated movie Y N stars. And maybe we can use Spark Streaming for that. Storm would also be a perfectly appropriate solution as well. Now we got to dump that behavior data somewhere, and since we're dealing with small little records here, HBase seems like a good solution here. Now originally we talked about Cassandra as well, and that could do it as well. I mean, Cassandra would be a perfectly good alternative here, or something similar to Cassandra. But in this case, I went toward HBase, and I'm kind of like thinking of a fictitious company here where, first of all, maybe I have an existing Hadoop cluster and that I can leverage, so somebody else can maintain the storage of all this data for me. That'd be kind of nice, right? And maybe because of the nature of what we're doing, we're going to want to do a lot of experimentation and analyzing of that data. So as we come up with new movie recommendations algorithms, I want that ratings data in a place where I can get access to it from a wide variety of tools. And there's a lot of things that run on top of HDFS and HBase. So for that reason alone, I might tip the scales toward HBase instead of Cassandra. Again, Cassandra would be the ideal solution from an end user standpoint, but HBase has high availability configurations you can set up, so you really don't have to give up much on the availability front these days in reality. HBase would be a perfectly okay solution. And MongoDB could fit the bill as well. But, if I had an existing Hadoop cluster and tools built on top of Hadoop, HBase would be my better choice there. So, once we have that user ratings data in HBase, we can have a Spark job that runs maybe once a day, orchestrated by Oozie, that uses that user rating behavior data to compute what movies are similar to each other. So movie A is similar to movies B, C, D, and E. People who like Star Wars also like The Empire Strikes Back and Return of the Jedi and Indiana Jones, whatever it might be. So that can run infrequently. That's the hard part. That's the heavy lifting of this whole system. And Oozie can kick that off daily and update back into HBase a separate table that just has relationships between movies. What are the similar movies to each movie that I've seen? Okay, so now that we have all of the customer behavior data, all the user ratings, and all the movie similarities sitting in HBase, I can very quickly provide that to my recommendations service. And that's some custom-built service that you develop to actually implement the item-based collaborative filtering algorithm. And maybe that's distributed using Slider on Yarn on top of your Hadoop cluster. That would be a pretty good choice. Or maybe you have some Docker-based system internally for deploying these sorts of services. Whatever, it doesn't matter. But that recommendation service can quickly get it the information it needs, namely the stuff that a given user has rated in the past and stuff that's similar to that stuff. So then when your application servers say, hey, I need movie recommendations for user ID 123, my recommendation service can say, okay, HBase, give me all the past movie recommendations for user 123. Let's take the good ones and find similar movies based on my other table of movies that are similar to other movies, and get the list of all the movies that are similar to the ones that this guy has liked, filter out the ones he's already rated, and give that back as the recommendations that I'm going to display on the front end. So, again, more than one way to do it, but this is one architecture. I could just as easily swap out Storm for Spark Streaming, Kafka for Flume, HBase for Cassandra, and in fact, there's a pretty strong case to actually use Cassandra here instead of HBase, but it depends on your other requirements. And notice also that I've tried to minimize the number of different technologies here. So one motivation for using Spark Streaming instead of Storm is that I'm using Spark over here. So instead of using Spark and Storm, why not use Spark for both? You want to minimize the number of different technologies that you're using in a given system because that makes it simpler to maintain and simpler to understand and simpler operationally, right? If the less technologies that the people that need to maintain and build upon this system need to understand at a visceral level, the better. So, and again, I could have chosen to use separate database technologies for the movie similarities and for the behavior data. And in fact, it might make sense to actually have those in their own cluster, but why would I put one in HBase and one in Cassandra if I can use the same for both? So again, that would also inform my architecture. So I have a definite bias towards simplicity in this design. I'm trying to make this data accessible to other people who might need it. But most of all, I'm working backwards from what the customers need, and I'm fulfilling what they want at the end of the day, which is good movie recommendations based on their past behavior data, based on up to the second information about what they've been rating. So there you have it. One implementation of an architecture for vending movie recommendations at large scale.